Hi Chem Peeps. Today we're going to talk about colligative properties. I'm going to be putting up not only this informational video but several videos following this that show examples of applying mathematically this property. So what is a colligative property? Well, colligative property is when the physical properties of a substance, in this case I'm talking about water, but it can be any liquid actually, when something else is dissolved in it. So, for example, I'm just going to draw a very crude example here. If I have a beaker of water, okay, and I'm going to use circles to represent the water molecules. So as I heat this and it starts to boil, the water molecules escape into the vapor phase, which we all understand and know. But if I was to dissolve, let's say, salt in here, now with the triangles, I'm letting that represent triangles, the triangles or the salt slow down the vaporization of the water as I heat it. And so what's going to happen is I'm going to have a higher boiling point because it takes longer for the water molecules to get around the dissolved particles in order to vaporize. We can say the same thing when we talk about freezing. So to freeze, water molecules must align into a crystal to form ice. Okay, so if I have a solution that is freezing, and I'm going to let the circles be water again, but then I dissolve, let's say, salt in there, and those are going to be the black triangles. Now the water molecules must get around and organize without the salt. And so what's going to happen as it takes longer for the water to align itself into its crystal, oops, not that one, the freezing point is going to be lower. So we know that water boils at 100 degrees. Well, when we add colligative properties, it's going to be higher than 100 degrees. And we know water freezes at 0 degrees. Well, with colligative properties in it, it's going to depress. Also, I'm going to show some videos applying this, but with colligative properties, substances dissolved in the liquid, we will lower the vapor pressure. In other words, what does that mean? Well, we saw over here that the water was becoming vapor up here. When I have solids in there, less of them are going to be above the surface because less of them are going to be able to escape. So we're going to explain all that in the videos to come. So if we look here, some things to remember. It doesn't matter if the dissolved particle is an electrolyte or a non-electrolyte, and I'll talk about that over here in a minute. The degree that we're going to change these properties is dependent on the concentration of the particles you dissolve in it. The more particles you put in it, the more it changes the properties of that liquid. So the more solid particles, the greater the effect. And electrolytes will have more bang for the buck. In other words, the more if you put equal concentrations of electrolytes and non-electrolytes, the electrolytes will change it more. So let's talk about why that is. So looking over here on the right, we need to remember when we talked about ionic compounds. So an electrolyte is going to be something that is ionic. And that is basically going to be a metal with a non-metal. Unless we're talking about acids, which I didn't really talk about acids, but if you come across an acid, acids do dissociate in water, and so they will also have this impact as well as ionic compounds. So here we have table salt. Table salt is made up of sodium and chlorine. That's a metal with a non-metal. In water, when it's dissolved, it breaks into sodium ions and chlorine ions. So even if I have one mole of the solute over here, you can see I get 2 particles when it dissolves. Here we have, in the next example, calcium chloride. There's 1 calcium and 2 chlorines. Even though I may have 1 mole of it, When it dissociates, I get a calcium and I get 2 chlorine. So I get 3 particles for every 1 mole. And here, this last one is sugar. We have 1 mole of it also, but it is covalent. How do I know it's covalent? It's metals with, or it's nonmetals with nonmetals. So we have carbon, hydrogen, and oxygen. They don't dissociate. So I only get 1 particle out of that 1 mole. It doesn't dissociate. And so you can see that electrolytes or ionic substances are going to have more particles. Those number of particles is called the Van 't Hoff factor, and we're going to use that mathematically. So you can see up here with sodium chloride, I had 2 particles, so the Van 't Hoff factor is represented by I in an equation, and I would have a 2 there because it breaks into 2. Calcium chloride would have a 3, and sugar would have a 1. Okay, so I hope this helps you understand colligative properties. Let's go to the next video on do some mathematical applications. You can find me on TikTok and YouTube at Kim's Kim Chat. Leave me a like or a comment, and I'll see you next.